Okay, this section is for 11.4b, properties of logs. So we're going to have several properties that we're going to use. The first property is our product property, which tells us if we have a log with a base of b of m times n, we can split that up with addition and make it log base b of m plus log base b of n. So some examples that we have here, if we have log base 3 of 4x and we're asked to expand that, we could make it log base 3 of 4 plus log base 3 of x. Where, for example 2, we're asked to simplify. If we have log base 7 of 9 plus log base 7 of 8, we could write that as log base 7 of 9 times 8. So, of course, log base 7 of 72. Alright, so that is our product property. In a similar manner, we also have what we call a quotient property. And with the quotient property, our log base b of m divided by n can be broken up using subtraction, as we see here. So if we look at some examples here, if we have natural log of 4x plus 7, we could break that up into natural log of 4x minus natural log of 7. Natural log of 4x could be further broken up because we could make that natural log of 4 plus natural log of x minus natural log of 7. And that would be completely expanded. If we have a problem like example 4, we've got the common log here, so we've got log of 9 minus log of 3. So that would be log of 9 divided by 3, which of course we could write as log of 3. Okay, so that is our quotient property. Our next property is the power property. Whenever we have log base b of m to the p power, we can take this power and we can pull it out front as a coefficient, as you see here, p times log base b of m. So if we look at our examples for this, for example 5, we could take this 3 right here and we could pull it out front. So that would give us log and 3 times log base 3 of 4x. Then we could go a little further and we could break up log base 3 of 4x. But we would need to make sure that we have parentheses here because that 3 needs to be multiplied by both of these. So we'd have log base 3 of 4 plus log base 3 of x. And that would be completely expanded. If we wanted, we could distribute that 3 there and have 3 log base 3 of 4 plus 3 log base 3 of x. That would be fine also. If we're asked to simplify, the first thing we want to do here is take our coefficients inside of the log as exponents. So we would do that for both of these. So we would have log base 2 of x squared plus log base 2 of 4 to the third power. So log base 2 of x squared plus log base 2 of 64. And then, since this has an addition between it, and we have the same base for our logs, we could write that together as log base 2 of 64x squared. We could write that together as multiplication. And that would be completely simplified. The next property we've really already looked at a little bit. It's called the equality property, and if we have log base b of m equals log base b of n, then we can say that m must equal n. So, if we have an equation like this, we have log base 3 on both sides. So we can set these things equal to each other. Our only problem is that we have this 2 on the outside of the log base 3. So in order to get this so we just have log base 3 of something equal to log base 3 of something, we can pull that 2 in as an exponent. So that will give us log base 3 of 4x equals log base 3 of x plus 1 squared. So now, at this point, we have log base 3 of something equal to log base 3 of something, so we can drop those logarithms on both sides. So I have 4x equals x plus 1 squared. So 4x will equal x squared plus 2x plus 1. You're multiplying that out, x plus 1 times x plus 1. This is a quadratic, so we'll move everything to one side to solve. So I'll subtract that 4x. So I'll get 0 equals x squared minus 2x plus 1. We can factor this, and when we factor this, we'll have x minus 1 times x minus 1 equal to 0, so we get x equals 1 as our answer for this problem. Okay, whenever we look at a problem like this, we're going to have to do a little more simplifying. We notice everything is in terms of log base 12, but we have all of this stuff that is on the outside of the logarithm. So what we need to do is we need to take this 1/2 and pull this in as an exponent. We need to take the 1/3 and we need to pull it in as an exponent. So we'll have log base 12 of x equals log base 12 of 9 to the 1/2 power plus log base 12 of 27 to the 1/3 power. Now, when we have 9 to the 1/2 power, that's really the square root of 9. So we've got log base 12 of x equals log base 12 of the square root of 9 plus log base 12. Whenever we have 27 to the 1/3, that is the cube root, 27. So this is log base 12 of x equals log base 12 of 3 plus log base 12 of 3. So here we have log base 12 of x equals log base 12 of 9, because we would do 3 times 3 here. So now at this point you can drop the logarithms, so x equals 9. We have another example here that I have written all over. Erase this over here. This is x equals 9. So over here we cannot solve for this while the logarithms are separated. So over here on the right-hand side or left-hand side, we're going to say log base 6 of 9x equals log base 6 of 54. So now, since we have everything inside of our logarithm on both sides and the bases match, we can drop those logarithms. So we'll have 9x equals 54. If we divide by 9, we get x equals 6 for our answer to this problem. I do want to add one more example.
Carrie Mullers, please call the high school office.
Sometimes we'll have equations like this. 2 log base 3 of x plus log base 3 of 4 equals 9. So in this case, we do want to combine our logarithms. We need to pull this 2 in as an exponent, so that will be log base 3 of x squared plus log base 3 of 4 equals 9. And then we can combine these together, so log base 3 of 4x squared equals 9. Now at this point, a lot of students want to drop the logarithm, but we do not have a logarithm on both sides. So rather than drop the logarithm, what we're going to have to do is we have to rewrite this as an exponential. 3 to the 9th power equals 4x squared. So we'll grab our calculators for this, because 3 to the 9th power is going to be a very large number. And 3 to the 9th power is 19,600. 983 equals 4x squared. So we will divide by 4. And whenever we do that, we get 4,920.75 equals our x squared. And then we will square root both sides. So we will take the square root of that answer, and we will get plus or minus 70.148 is our x. Now we do need to look back at the original equation. We cannot take a logarithm of a negative number. So right here where we have 2 log base 3 of x, we cannot plug in the negative 70.148 here. So the only answer that we will actually have will be 70.148, and that is an approximation that has been rounded